In section 2.6, we are going to learn about derivatives of inverse functions. But before we get into the derivatives, let's first talk about some specific inverse functions. And those are the exponential function and the logarithm function. Those are inverses of each other. And the preliminary idea, or the idea of inverse functions, is that they undo each other. So if we have the log function, log of x is equal to y, it means that the same thing as y is equal to 10 to the x. So the exponential function 10 to the x and the function log x are inverse functions of each other. They flip-flop like input and output. So the input of the log function is the output of the exponential function and vice versa. Let's look at an example with numbers. One thing that these two equations are also telling us is the log of 100 is 2, and that means the same thing as saying that 100 is equal to 10 to the 2, and that is a true statement, right? So the log is really the exponent you have to take 10 to get 100 in this case. So right here, the output of a log function is an exponent in the associated exponential function. Now, log uses a base of 10, so it corresponds to the exponential function 10 to the x. When we talk about the natural log, or ln of x, then we are talking about the exponential function e to the x. So the ln of x is equal to y means the same thing as y is equal to e to the x. Graphically, we see over here on the right, we see the natural log function and we see the exponential function e to the x, and they are mirror images of each other. Well, reflections across that line y equals x. So if we are taking a point right here that has input a and output b on the logarithm function, then we have the corresponding point that flip-flops input and output on the exponential function. So if a comma b is a point on the graph of y equals ln x, then b comma a is a point on the graph of e to the x. Now, because they are inverses of each other, there are lots of properties for logarithms that we might already be familiar with, but I want to write those down again. One thing, because they are inverses of each other, if you take the ln of x and then you raise e to the ln of x, you undo whatever the ln did. So if you first apply the ln and then the exponential function, you get your input back. So e to the ln of x is equal to x. And in the other direction, this also works. If you first look at e to the x and then you apply the natural log to that, you also get x back. So that's what it means that the two are inverse functions. Now, the ln of some other constant to the x is equal to x times the ln of a. So you can rewrite the ln of a to the x as x times the ln of a. And the ln of x times y is equal to the ln of x plus the ln of y. We have a similar relationship for the ln of x over y. The ln of x over y is equal to the ln of x minus the ln of y. So these are all properties of logarithms that correspond to similar properties of exponents that come in handy when we want to solve equations or when we somehow need to transform a function to look differently. Now, all of these properties I've written down right now. are in terms of the exponential function and the natural logarithm, so the exponential function e to the x and the logarithm ln x, the natural one. We have, of course, similar properties for the log log function, the one base 10. So 10 raised to the log of x is also equal to x, and the log of 10 to the x is equal to x. The log of a to the x is equal to x times the log of a, and the log of x times y is equal to the log of x plus the log of y, and the log of x over y is equal to the log of x minus the log of y. Now you could have a logarithm that corresponds with any exponential function, 3 to the x, 5 to the x. Any of those have a corresponding log, which you would call log base, whatever that is. So like 2 to the x has the corresponding log base 2 of x as an inverse function. But in this class, we mostly will be working with the natural log, so the one corresponding to the exponential function e to the x. And you may see the log base 10 in some of your other classes, but we will not be working much with it for the rest of calculus. So it's really the exponential function e to the x and the natural log that we will become most familiar with.